welcome back, and we were discussing in the previous lecture about the different type of rocks, and this now tilted sedimentary rocks. Okay, now this is typical of, because as we have learned that the sedimentary rocks will form or get deposited, initial deposition, and then finally the cementation will lead into a very horizontally stratified sequences. Okay. So, tilted sedimentary rocks by folding, intrusion or faulting result in the exposure of sedimentary rocks to variable rates of weathering and erosion. Thus, the harder rocks, okay, form ridges, whereas the softer rocks forms elongated landforms. Okay. Then drainage pattern ranges from trellis to annular depending on the nature of the folding and faulting. Okay. So, this we have already discussed in the type of drainage pattern. You can refer to that, and this will help you in identifying the different terrain. Okay. And they are often you usually can find one side of the ridge is steeper than the another one. Okay. So, typical pattern like this, okay, you will be able to see because this is because of the tilted layers. Okay. Now, the pattern of phototones is often banded, reflecting differences in the rock colors, okay, and nature of vegetation growing on the soil formed from the underlying rock. Okay. Fractures and faults are often clearly visible in such areas as the streams and rivers take advantages of these points of weakness in the rocks, okay, and forms the valley. Okay. Now, this particular point, what it tries to pinpoint is that if you are having fractured rocks, okay, and typical fracture pattern is there, then the drainages will try to follow this line, okay, or I may take in different color here. The drainage which will try to follow this pattern, okay, and this will give you a typical rectangular pattern, or you can say if you are having the folded terrains, okay, for example, then you will come across if you are having the linear folds like this. Okay. Now, when we say that they are folded, then the resistive rocks, okay, will form the ridges, whereas the non-resistive, which are easily eroded, will form the valleys. Okay. And trellis pattern, usually you will see that you have the flows like this, okay, and then you have the drainages which are joining from here, okay, like this. Okay. So, please refer to that what we were talking about. Okay. In the we have already discussed this in the different type of drainages, okay, or drainage pattern. We can easily make out the this is in coastal area, but you can look at the different layers, okay, or the different stratas in sandstone or the sedimentary rock here, okay, what we see, and we can easily make out the tilt, okay, and then different beds, okay, and then easily eroded rocks are here. What we see are forming the landform, the flat platforms. Okay. Another important feature, okay, which we can look at the different typical drainage here, okay, and a very flat lying terrain, okay, and a typical sedimentary rocks. Okay. So, you can identify the different based on the different tonal variations, the different lithology where you have sandstone and you have a different material or the rock which has been seen here. And also you can see this beds, okay, which are aligned here. Okay. We have seen in the previous photograph that was a sectional view where we were looking at the horizontally stratification in the sandstone which or the sedimentary rock, okay, which is seen here. But suppose you are looking the terrain which is folded and deformed area comprised of the sedimentary rocks, okay. So this is an example of the photograph. The satellite data which you see here is in cartosat data, and what we were talking about right from the beginning, that we should look at the tonal variation, we should look at the structural elements which are preserved on the surface, and then the drainage density and all that, okay. Now this is a cartosat photograph of from Himalaya, which tells us that we may face slight difficulty in identifying and strictly following the parameters which we have talked about, okay. But nevertheless, based on the other parameters which we can use to identify the terrain, you can use that, okay. Now if you see on this area particularly, okay, what you are able to gather, okay, that you have a very typical feature which reflects, of course, that there is a drainage here, and then you are having a closely spaced drainage on this side, whereas you are having very sparsely spaced or widely spaced drainage, okay. So this two portion clearly indicates that these two are having probably in different lithology, okay. Now another thing which you can make out here, that as we were looking at the vertical or the face of the sedimentary rock cut along the coastal zone, here you can see the small, or we can see the linear lines, okay, which are oriented in one particular direction, okay. Now these are typically of folded sedimentary rocks which are the top has been eroded, so you see that they are all vertically stacked, okay. So this also helps you in identifying this, okay. At the same time, if you see on this side, you are having quite a different lighter tone, whereas this is darker, okay. So this darker tone is just because of the thick vegetation, okay. So this is a thick forest area or the forest cover, but based on these bedding plains vertically stacked, okay, you can talk about that this is sedimentary terrain, and this is modified areas by the local people and used for the cultivation, okay, or the agricultural lands, okay. And then if you again see here in a very small portion here, okay, this one, you can easily make out that this area is folded, okay. Very small folds are been seen here, and then you have again very vertically stacked tree units, okay, and similarly you can see this one also here. So these are in typical of and vertically stacked sedimentary terrain or the sedimentary rocks, okay, and this can happen only if you the whole layers, okay. Like for example, you are having in very horizontal deposited layers, okay, and then when you fold it, okay, you are able to do that, okay, and then finally if you erode this from the top, okay, then on the surface you will be able to see those vertically stacked units, okay, and that what we are able to see in this area. So similar exercise we will keep doing for this particular course, and you will be given some lab exercises where you can try to do the photo interpretations, okay. So this was basically for the sedimentary terrain, and few more examples we will talk at the time of when we are doing the labs. Now coming to the igneous rocks particularly, okay. Now the igneous rocks we usually don't see the typical beddings and the foliations, okay. And in terms of the massive the intrusive rocks, which are usually massive and homogeneous, okay, these are typical what we see granitic in the granitic terrain. Okay, they are often well jointed, which can be easily mapped on the remote sensing data due to vegetation and moisture differences. Okay, then it will also show dendritic pattern, or you will have rectangular or angular pattern depending on the jointing pattern. Okay, occur in different shape and dimensions. Okay. Now, in terms of the extrusive rocks, okay, so these are the intrusive rocks. Typically granite extrusive rocks you will see, like for example basalt, okay, associated with volcanic landforms such as lava flow, cones, crater dikes, etc. Okay. Intrusive igneous rocks in particularly, okay, we also term this as a plutonic igneous rocks, and they are formed by molten material rising within the earth but never reaches the surface. Okay, thus experiencing slow cooling and solid, it remains solid and unbroken nature. Okay, later if exposed to the surface by erosion of the overlying rocks, okay, these rocks form impermeable surface on which dendritic or rectangular patterns are well displayed. Okay. Gullies will be wide and U-shaped. Okay. Light tone often indicates area of granite, while darker tones express the presence of gabbro and andesite. And this is also a type of an intrusive rocks. Okay. So, now in terms of the extrusive rocks, they are formed by the quick cooling and solidification of molten matter. Okay. For example, lava flows, the material is often highly jointed or fractured due to rapid cooling, okay, and more susceptible to weathering and erosion than compared to the intrusive rocks. Okay. A drainage tends to be rectangular to parallel with coarser texture, okay, because of the permeable nature of the rocks. Okay. One might find radial drainage pattern indicative of volcanic cone development. Okay. Light toned areas indicate rhyolites, darker tone indicates basalt, and lava flow areas often appears as dark tone sedimentary rock. Okay. Similar to a sedimentary rocks where you are having a lava flows, okay, forming stair steps, valley walls, okay, when the lava are of different resistance to erosion. Okay. Igneous rocks, okay, which are formed by quick cooling and with the material, the molten matter is coming on the surface. Okay. Now, for example, the lava flow, which usually you will find is a fine grain, but they are highly jointed and fractured due to rapid cooling, and the drainages which you will see mainly, depending again on the different type of rocks, because you cannot say that the extrusive igneous rocks are all of same kind. Okay, it will have different types and all that. Okay, depending on even the grain size will vary. Now, the basically what you will be able to come across that the landforms which you are having the radial drainages, okay, you will see where you are having the volcanic cones, okay, and the dark lighter tones you will see if you are having rhyolite, whereas the darker tones in terms of the basalt, and in some cases you will also see that basaltic terrain will show the closely spaced drainage. Okay, fine. Now, this is typical of volcanic plateaus which you will come across in an igneous terrain. What you have is very flat plateau like feature here. Okay. and typical of here too. Okay. So this will clearly talks about the volcanic terrain mainly, and this one is a photograph from Deccan Plateau, India. Okay, where you have the darker tone. Okay, due to the black cotton soil. Okay, and the vegetation is sparse, and the terrain is marked by high density dendritic drainage. Okay, and this because one thing which you will see in typical of dendritic drainage is if you are having a monotonous terrain. Okay, and coming to the further important parameters for the granite: weathering, more in humid warm climates, and mainly what you will see a sort of an spheroidal weathering. Okay, as compared to that of in the cold dry climates, bodies of gigantic dimensions. Okay, so if you go in South India, you will be able to come across the huge boulders. Okay, or the gigantic boulders of the granitic bodies. Okay, low lying topography is also you will be able to see. Okay, fine. And then the drainage density mainly will be low to medium. Okay, when mostly you will see because of its typical fracture pattern and all that, you will come across a rectangular to angular drainage. Vegetation it doesn't support much, so you will have mostly the barren terrain. Okay, in terms of the spectral characteristic, light to medium toned, low emissivity band due to quartz. Okay, and feldspar. So this is again the reflectivity will depend upon the mineral composition of a particular rock. Okay. Now coming to the metamorphic rocks mainly. Okay, they are marked by foliations and very faint stratifications. Okay, foliations are manifested as numerous photolineations. Okay, parallel to one another. I will show in the next photograph or the slide where we will be able to easily make out a typical linear features. Okay, what we are talking about, the photolineations. Okay, the examples of the metamorphic rocks are quartzites, you have marbles, schist, phyllites, slates, and gneisses. Okay, so metamorphic rocks. Now if you take gneissic rocks, the gneissic area shows almost similar characteristics that is seen in a granitic terrain. Okay, but of course you will come across you can make out easily that this is a granitic terrain and this is a basaltic, but yes, of course you may come across the granitic gneiss. Okay, which will be seen in form of boulders also. Okay, show prominent hill topography, dendritic drainage to parallel of the main stream. Okay, and this is the main difference between the drainage in granite and metamorphic terrain. Okay, so in granitic terrain you will not be able to see a very good drainage pattern, but here you will see drainage dendritic to or you will the parallelism will be seen to the of the main stream. Okay, drainage shows some angularity. Now in terms of the schist, which shows rounded hills, very fine drainage. Okay, a rectangular to angular pattern referred as waffle pattern, like hairy appearance. Okay, slate, deeply dissected hills you will see, and a rectangular drainage controlled by joints and cleavage planes. Okay. Now in terms of the quartzite, which is the most resistive rock, okay, in both high dry and humid climate, landforms, if you see, you will come across hills, ridges, scarps, and topographic very prominent topographic features. Okay. Low to medium density drainage you will come across, because of steep slopes, okay, and of course because of its high resistance to erosion. Okay. Vegetation, massive quartzites are mostly barren. Okay. Weathered, impure quartzites may support to some extent good vegetation. Okay. They are coming to the spectral characteristics. Mostly it is been seen it is light toned. Okay. And if you look at, we have low emissivity bands due to quartz and feldspar. Therefore, it gives a darker appearance. Okay. And furthermore, here about the weathering part. Okay. Now, typical of metamorphic terrain, you will see in very linear features here, and since they are highly deformed, you can come across the folded metamorphic status. Okay. And this is a typical landscape which one can see here. Okay. So you can see these bands here. These are not of the sedimentary terrain, but this is of typical of metamorphic region. Okay. Straight lineations you can make out and pick up here. So what we will do is we will pick up all three environments, okay, like igneous, metamorphic and sedimentary, and we'll try to give you in labs, okay, so that you can identify that. Okay. Now coming to schist, phyllites and slates, they are generally incompetent rocks. Okay. Landforms, valleys and lower hill slopes, rounded forms in humid climate. Drainage, again you will have dendritic, well developed, drenal density will be comparatively higher, controlled by foliations. Okay. Vegetation fairly good in humid climate, sparse in arid. Spectral characteristics again depends on the mineral composition. Okay. Iron rich minerals produces darker tone and blue green bands. Okay. And so in blue green bands you will see a darker tone if you are having the iron rich minerals. Okay. Similarly, in terms of the Gneisses, okay, as we were talking in one of the slides, that this shows a very typical pattern like granite. Okay. So they are quite good resistive rocks. Okay. Then schist and phyllites, but lesser than quartzites. Okay. Landforms which you will come across will be low lying, undulating terrain, rounded smooth surfaces of the landforms. Density will be comparatively higher. Subparallel drainages are often seen, and also rectangular pattern. Okay. Good vegetation cover, again the spectral characteristic, highly variable spectral bending of dark and light tones may be prominent. Okay. So in terms of the schist, because it will have the darker minerals as well lighter minerals. Okay. So you will be able to make out that variability in the spectral characteristics. Okay. Now erosion or the ravines, okay, in particularly the characteristics of erosion gullies depends upon the nature of rock types, grain size and the permeability of the material, okay, and the intensity of the geomorphic agencies working on them. Okay. These features can readily be studied on the aerial photographs. Okay. Now gullies in gravel have V shaped, okay. Those in silts will have U shape, okay. Or those in clay softly rounded forms, and in silt and sandy soils they have minutely granulated forms. Okay. This is one of the good example, okay, of terrain basically, where you can see the lighter and darker tones, okay, of different rock types here. Okay. So what you can make out here clearly again is that very drainage, okay, widely spaced, and a typical of could be an folded terrain here. Okay. But this is the basic idea behind the identification of different sedimentary rocks or the sedimentary terrain where you can see the tonal variations. Okay, and on the left what we have tried to explain is that, okay, so this is then the extracted information which shows the valley and the boundaries of the valley here, okay, which you can see that eroded rocks, and then different type of rocks which are been exposed here are also been seen. Okay, so this exposed rocks within the valley will give you this tonal variations here, what you can see here. Okay, so there is some wide valleys here, and then you have the tonal variations of that. Okay, so this you are able to see, which usually is difficult to see in the landscape, in the section. Okay, but when it is exposed within the valley, one can easily make out, and this is what been picked up on the satellite photos. Okay, thank you so much.